Hi Dominic, it's Mrs. Jennings. So I'm going to start the video for Thursday. What we're doing in class today is number one, I'm going to give the kids a chance to ask a question on Weekly Skills 8, which they got Wednesday. So when I see you next time, if you have any questions on Weekly Skills 8, you can either ask me then or you can email me. That is the first exam review. You'll get another one next week. Weekly Skills 8 is due next Wednesday, okay? And then the next thing that we're going to do in class is you should have gotten a weighted average worksheet, number 2. It looks like the one that I have in the picture. So what I am doing in class on Thursday is I'm giving them about 10 minutes to do the first 3 problems. We're not even going to touch the back. So what I want you to do right now is I want you to turn the video off, take about 10 minutes to do those first 3 problems. I will give you a couple of hints. Look at number 1. It says hint, total cost $3.30 is for the soup and the salad. As you read that problem, it almost looks like that the soup is a total of $3.30, but that's actually the total cost of the mixture of soup and salad. And number 3, I will tell you, it will not come out as a whole number, so just round the answer to the nearest tenth. So when you are ready and you have those 3 done, start the video again and I will go over the answers to them. Okay, Dominic, so I have given you the answers. Number 1 is 9 ounces of salad. Number 2 is 6 2/3 of the 60% solution. And then number 3, the answer is 6.4 pounds of the candy too. Now, if you get all 3 of those right, feel free to fast forward the video. If not, I'm going to go over real quick how I did each problem. So number 1, the 3 things I put in my chart was we were having soup and salad, and then of course the cost was the mix of those 2. The soup, we had 10 ounces and it was 15 cents an ounce. The salad was 20 cents an ounce. That's what we're trying to find out, is how much salad did Tasha buy. The mix, we don't have to put anything in for the amount or the cost per ounce. All we have to worry about is the total cost of soup and salad together is $3.30. So I let my variable be X is amount of salad. My total column, I multiplied how much I had times how much it was. And of course, again, the mix was $3.30. Plugged it into the equation, solved it, came up with 9 ounces of salad. And of course, you can compare your work and my work if you did not get that right. Number 2, 6 2/3 milliliters of 60% solution. So my chart was made up of 25%, 60%, and the mix is 30%. The second column there, what I did was I just changed my percents to decimal so I didn't forget. I had 40 milliliters of the 25% solution. I had X of the 60% because it says how much of the 60% are we adding. And then the mix is the 25% plus the 60%, so X plus 40. The last column, I multiplied those 2. My variable is the amount of 60%. As you can see in the right, I worked out the problem. The answer comes out to be 6.6 repeating, but at this point we need to know that 6.6 repeating is really 6 2/3. And then lastly, number 3, we had 2 kind of candies that we were mixing, so I called it hard candy 1 and hard candy 2. The first kind of candy is $5.45 a pound, and the second hard candy is $7.33 a pound, and we're making a mixture that is $6.14 per pound. It says how many pounds of the $7.33, so that's X, is mixed with 11 pounds of the hard candy 1, so the mix, we have a total of X plus 11. The total column, multiply those first 2 columns. My variable is X's amount of hard candy 2. Again, over on the right, I worked it out. Sorry, it gets a little small there. And it comes out to be a really weird number, 6.397, something like that. So I rounded to the nearest tenth. So, Dominic, our new topic for today is something called compound inequalities. Compound inequalities are just like in English, if you've ever heard of compound sentences. Technically what it is in compound sentences, two sentences joined together by a conjunction. Well, in math, compound inequalities are two inequalities that are joined together by a conjunction, but we only have two conjunctions in math, and that's and or. So here's an example of how these are used in real life. So if your mom tells you you can go to the mall or you can go to the movie, that would tell you you can do one or the other. You cannot do both. And would be if your mom said you can go to the mall and you can go to the movie. That means you get to do both of them. So we have to understand the difference between these two words. So what our problems are going to start looking like is something like this. 2x plus 4 is less than 8, and negative 3x minus 10, or 6, whatever I write, is less than or equal to 8. It'll look something like that. They can look any various ways. So what we have to do is we have to find out what answers are going to work for both of these inequalities, because I want to find out what are the solutions to 2x plus 4 is less than 8, and what are the solutions to negative 3x minus 6, which is less than or equal to 8. So we want to actually find out what answers work for both of those at the exact same time. Okay, not quite ready for this problem, so we're going to go on. All right, so first thing we have to Okay, so Dominic, I just wrote a very simple inequality. X is greater than 2 and x is less than 7. So if I asked you what are some answers to this problem, I would hope you would say something like 3, 4, 5, 6, because 3, 4, 5, and 6 are greater than 2 and less than 7. But, of course, we have to remember there's a whole lot of other numbers besides 3, 4, 5, and 6. There's 3.2, 3.1, 3 1/3, 5 1/2. We have to have some way to show all the answers to this problem. So what we're going to do is, it actually is going to take a couple of times of seeing a couple of graphs, and then you'll see where we're going with this. So first of all, what I'm going to do is I'm going to draw my number line like I always do for an inequality. I'm going to put 0, and then I am going to first graph x is greater than 2 in red. And we know that's how it would look. And then I'm going to graph x is less than 7 in blue. And somewhere here in this graph is the solution to our actual problem. So if you think about the word and I said Dominic can go to the movie and he can go to the mall, that means you get to do both. So what we're looking for in this problem is, where are the answers that solve both of these problems at the same time? Well, in this case, it's where do my two colors overlap at? So it's right here. So what I would do is, this is not my final answer because that doesn't really tell me you know what the answer is. So the final graph, which I call the final draft, because you know how in writing you always do a rough draft and a final copy. So my final copy of my answer would be, here's 0, here's 2, here's 7. Where did they overlap at? They overlapped between 2 and 7, and the 7 and the 2 have open circles, so my answer is everything between 2 and 7. Now, I will tell you, in compound inequalities and an and, they're not always between them. You'll see what I'm talking about as we go forward, okay? Okay, so here's another example. We aren't solving anything yet. We're just talking about how do these compound inequalities work. So my problem is x is greater than or equal to negative 7 and x is greater than 10. So we want to find the solutions that work for both of these inequalities at the exact same time, okay? So it's where are answers that are greater than or equal to -7 and greater than 10? Well, if you can't think about that in your head, which I'm sure you can, we have to visualize it on a number line. So I'm going to draw my number line. And again, I'm going to make my rough draft. So here's my -7, here's my 0, here's my 10. So my x is greater than or equal to -7 is in red. So it's going to be a closed circle, shade to the right. And x is greater than 10 is going to be an open circle, shade to the right. So and means where do my solutions overlap? Well, if you notice, I'm going to look at it in yellow. Where do they overlap at? Well, the red and the green would be over here, okay? So my final answer to my problem, my final draft, I don't even need -7 on my graph because over here, I'm going to do this in green, over here, nothing here would match and work for both of the inequalities, so we don't even need that section on my final answer. So my final answer is, where do they overlap? Well, it's right here. So I have 0, I have 10. Because the 10 has an open circle on it, it's an open circle and greater than 10. So anything greater than 10 are going to solve both of those inequalities at the top of the page at the same time. Okay, so we got one more and then we're going to actually start solving problems. This problem, y is less than 3 and y is greater than 12. So if you think about it, what numbers are less than 3 and greater than 12? I'm hoping you're saying to yourself, Mrs. Jennings had to make a mistake because there are no numbers less than 3 and greater than 12 at the same time, which you're right, but we have to see, I call this one a special case. If you look at the graph of this problem, and again, I'm going to do part of it in blue. So here's 3, I can put 0 on. Here's 3 going to the left. Here's 12 going to the right. Do those two overlap at all? The answer is no, which is obvious because there are no numbers that can be less than 3 and greater than 12 at the same time. Therefore, this problem actually has no solutions. So in an and, if our two problems or our two inequalities do not overlap, that's a special situation. That means we have no solutions to that. Okay, so now, Dominic, we're going to actually do problems where we actually have to solve them. So notice I've given you two inequalities. So at first, we just treat them as two separate problems. So I'm going to solve the one on the left, and of course, we're going to apply all of our rules of inequalities. If I multiply or divide both sides by a negative, I have to flip the sign, all that fun stuff. So let's see here. -2x plus 3 is less than 11. So I'm going to subtract 3 from both sides. I get -2x is less than 11 minus 3 is 8. I'm going to divide both sides by -2, and I get x is greater than -4 because I have to flip the sign because I divided by a negative. Okay, so then I'm going to put the word and. On the other problem, I'm going to add 2x to both sides, and I get 5x minus 5 is less than 15. I'm going to add 5 to both sides. I get 5x is less than 20. Divide by 5, and I get x is less than 4. So my two answers are x is greater than -4 and x is less than 4. So I've got to find out what answers that are in those two inequalities that overlap, they actually are solutions to both of the inequalities at the beginning of the problem. So I'm ready to graph. And again, I like to do two separate graphs until you're really good at this. So I have -4. Here's 0. I'm going to do greater than -4. Switch colors. X is less than 4. I like to do different colors just so I can see the overlap. So where do these two problems overlap at? They overlap between -4 and 4, which means my final answer is any number between -4 and 4, open circles, means any number between -4 and 4 are going to work in both of the beginning inequalities. If I plugged in the number 3 in both of the top inequalities, it would work in both. If I picked the number 5, it would work in the left one because the answer is x is greater than -4. It would not work in the right one, so we want answers that work in both, so 5 would not be a solution to both. Okay, so moving on to another one. Okay, Dominic, so here's my two problems. -1/2 x plus 6 is less than or equal to -14, and -2 times the quantity 2x plus 4 is greater than 8. And again, these just start out as normal problems. I have to solve them both following inequality and equation rules. So over here, I'm going to subtract 6. I get -1/2 x is less than or equal to -20. Multiply both sides by 2 over -1. Which means I'm going to flip the sign, and I get 2 negatives and make a positive, so x is greater than or equal to 40. Or you could have multiplied everything by 2 there and then solved it from there, however you wanted to solve that problem. And then the second one, of course, we have the word and. We're going to do the distributive property, -4x minus 8 is greater than 8. Add 8 to both sides. I get -4x is greater than 16. Divide by -4 on both sides, which means I have to flip the sign. Okay, so here are my two answers. I need to figure out x is greater than or equal to 40 and x is less than -4. So this is where the graph comes in. So here's 0, here's 40, closed circle, shade to the right, -4, open circle, shade to the left. Notice no overlap, because is there any numbers that can be less than -4 and greater than or equal to 40 at the same time? The answer is no. So that means there is no answer that is going to make both of my inequalities true at the beginning of the problem. There's no answers to both. So the answer is no solutions. Now, look at this next problem, Dominic. Notice that doesn't look like the last ones we've been doing. This one actually says, I know most people would look at this and say, it says -6 is less than or equal to y, which is less than or equal to 9. Technically, that's not how you read this problem. It actually says y is greater than or equal to -6 and y is less than or equal to 9. You always start with the variable. So notice nowhere in this problem does it say and, but I said it's an and. If a compound inequality doesn't have the word and or the word or, we automatically know it's going to be an and compound inequality. So technically this problem says y is greater than or equal to -6 and y is less than or equal to 9. So there's nothing to do to solve this one. We just have to graph it. So I have -6, closed circle, shade to the right, and I have 9, closed circle, shade to the left. That's just my rough copy. So where are my solutions? My solutions overlap between -6 and 9. So my final answer to this problem is -6, 9, closed circle on -6 because it was a closed circle in the top one and a closed circle on 9. My answer's in between there. Okay, so here's our next example, Dominic. This one actually says -2 times the quantity 3x minus 5 is greater than -4 and less than or equal to negative 6. Now, there's two ways you could do this. First of all, you could rewrite the problem as this. Negative 4 is less than negative 2 times 3x minus 5. And, because anytime there is no word, it's an and, negative 2 times the quantity, 3x minus 5, is less than or equal to negative 6. So I could do it like that if I wanted to. But I'm going to show you there's another way to do it. So I'm going to erase what I just did. And you're welcome to do it the way I just did it. Or you can do this other way. The other way you could do it is you can kind of solve this whole problem how it is. So I can do negative 4 is less than, do the distributive property, negative 6x plus 10 is less than or equal to negative 6. So if I look at the middle problem, and I can't show you this because I can't put my hand over it and let you see it. If I cover up the less than or equal to negative 6 and I ask myself what would I do with the rest of that problem, I hope you see that you would subtract 10. Okay, now if I actually covered up the negative 4 is less than and said how would I solve the rest of the problem, I hope you would say you would subtract 10. So no matter which way you start, you would subtract 10. So we're actually going to subtract 10 from all parts. And we get negative 4 minus 10 is negative 14 is less than negative 6x, which is less than or equal to negative 16. All right, so then if you look at this problem, how would you solve that middle part of the problem? I would divide by negative 6. So I'm going to divide by negative 6 on all parts of the problem. Now, because I'm dividing everything by a negative 6, that also means I need to flip the sign. Negative 14 divided by negative 6 is 7/3. In the middle, I just have x. And on the end, negative 16 over negative 6 is 8/3. So my answer is x is less than 7/3 and x is greater than or equal to 8/3. So I have no idea what the answer to this problem actually is. Now, when I do this problem, what I like to do now before I graph it is I like to write it as two separate answers. X is less than 7/3. I don't like things written backwards. And x is greater than or equal to 8/3. Okay, so let's think about our graph. Sorry, I'm running out of room here. So 7/3 has to be less than 8/3. So 7/3, 8/3, and we didn't put 0 and it's okay. So I would have less than 7/3, and I would have greater than or equal to 8/3. And look at that, they don't overlap. So that means the answer is technically no solutions. Would have never known that had we not worked it out. Okay? Okay, one last problem, and as you can see, it's a doozy. So is this an and problem? Yes, because it doesn't say the word and, but it's got two inequalities. Now, we can't do this one like the last one because we have all kinds of stuff pretty much everywhere. So we've literally got to separate this into two problems. So the first problem we're going to solve is negative 3x minus 10 is less than negative 2 times negative x plus 3, and then we're going to put the word and then the second part of the problem is, if I can fit it in here, I'm going to write it down here, negative 2 times the quantity negative x plus 3, so the middle part goes with both, is less than or equal to negative 4x plus, minus 6, sorry, plus 2x. Okay, so it's really two separate problems, and I just rewrote them. All right, so let's go to the red one first. So we have negative 3x minus 10 is less than distributive property 2x minus 6. I'm going to add 3x to both sides. I get negative 10 is less than 5x minus 6. Sorry, this is kind of messy. I try to write neat on here. I get negative 4 is less than 5x. Divide by 5. So x is greater than negative 4/5. Okay, we'll come back to that in a minute. Now let's solve the green problem. Again, distributive property 2x minus 6 is less than or equal to, I'm going to combine my like terms, so negative 2x minus 6. I'm going to add 2x to both sides. I get 4x minus 6 is less than or equal to negative 6. Add 6. 4x is less than or equal to 0. Divide by 4, which means x is less than or equal to 0. So my two answers are, and again, I like to turn this one around because I don't like them backwards. X is greater than negative 4/5, and x is less than or equal to 0. So, of course, I'm ready to graph. So I have negative 4/5, and by the way, when you're making graphs with fractions, you don't have to tell me what whole numbers they fall in between anymore because it gets too crowded on the graph. So I'm going to have, let's see, in red, I'm going to do greater than negative 4/5. Sorry, it's running into the work. And then in green, it's going to be what? Less than or equal to 0. So where do they overlap? They overlap in between. So my final answer is, I'm going to go up here and where I have space. My final answer to the problem is negative 4/5, 0. Let's see. Open circle, close circle, shade in between. So if we were taking a test or a quiz, this is what I would see for the answer. I would see down here, I would want to see this part, x is greater than negative 4/5 and x is less than or equal to 0, and I would want to see the graph. There will be a blank for each of those. Okay. All right, so Dominic, you should have gotten this paper, worksheet number 1, compound inequalities. So tonight, all I want you to do is the problems that have to do with and, because we haven't even talked about or yet. So you're going to do number 1, you're going to do number 2, let's see, you're going to do number 6, you are going to do number 7, and you're going to do 9 and 10. I didn't actually, my picture didn't include them. So those are the only problems you're doing for Friday. Hopefully this video helped. Hopefully it wasn't too confusing, and I hope it didn't take you too long to watch it. So see you soon. Hope everything's going okay. Email me if you have any questions. Bye, Dominic.